All right, here's some videos on polynomial functions and plotting points and finding polynomials. So the first question, they say the given point, that's this one, is on this graph. So on the graph of f of x, I have the point 2, 7. Then they say they have a function g of x, which is negative 2 f of x plus 1 minus 3, and they wonder what the new point will be. I have to give them an x value and a y value. So if this is 2, 7. So when I take a look at the transformations here, things inside the bracket are what affect x, and this thing here will move the graph, translate it left or right, and this one's going to move it left 1. So if my x value is 2 already, if I move left 1, then the x value is going to be 1. Okay, now these two values affect my y value. So they're going to affect y. So this first, the one I do first is this one here, because that's being multiplied, and this one that's being subtracted, I'll do last. So I need to take my y value, my 7, and times it by a negative 2, so that gives me negative 14. That takes care of that transformation. And then I need to move it down 3. So if I'm minus 14, if I go down 3, it'll be negative 17. So that'll be my transformed y value. And I've taken care of then this transformation and this one and that one. All right. Here's another question, and they ask us to find a polynomial. So I'm not transforming. So this is section, I don't know, 4.5, 4.4 or something. So they say degree 3, so it has to be x cubed plus something. And they say the zeros are 2, so x is equal to 2, x is equal to 2i, and x is equal to minus 2i. Notice that these complex zeros always come in pairs. So there's a positive one, there's also a negative one. Now, I want to get these back into a polynomial, so I want to change this into a factor, change this one into a factor, change this one into a factor, and then multiply them. To change them into factor, what you could do is just make it equal to 0. So if I have x is equal to 2, I can subtract 2 on both sides, and now it's equal to 0, and this will be the factor that I use. You can also think you just change the sign, so it'll be x minus 2, then this one will be x minus 2i, and this one will be x plus 2i. So far this is looking good for my polynomial, but now I probably should multiply it all out together. I'm going to multiply these two complex ones first, because I know something's going to cancel out. So x times x, x squared, plus 2ix minus 2ix, and then minus 4i squared. These two, one's positive, one negative, they'll cancel. So I have x minus 2 times that. And then, so this I have x squared minus 4. Oh, but I squared is negative 1, right? So negative 4 times negative 1 is a positive 4. So this would be x squared plus 4. And then I have to times that by x minus 2. Okay, so it'll be x cubed plus 4x minus 2x squared minus 8. And then I'd probably rewrite it so that it's in the proper order. So x cubed minus 2x squared plus 4x minus 8. So there's my polynomial of third degree that would have these as zeros. Okay, here's another question, and again it's a transformation question, and they want to know how can this graph be obtained from just a base graph. So I see inside the brackets there's a translation there, so I'm going to move the graph 5 units to the right, and then from this one that's a y translation, so I'm going to move things 1 down. So on a test, if you just told me that 5 right and 1 down, that's what I'm looking for. Okay, the last question is another translation kind of question. So they say, I had a function f of x So this function f of x has a point which is 4 and negative 8. And then they say g of x is f of negative 1 over 8x. Oh, and that's all. And so they want to know what the transformed point will be. Well, there's no value out front here, or there's no value out behind. This would be an A, or I think this is a D spot. I forget what the letters are. Anyway, there's nothing there, and those values affect y. And since there's 1 there and 0 there, so there's nothing to change, so that my y value doesn't change. So my end y value is going to be a negative 8. But I do have this term here, which in the video I call the B term. I think in the book they might have that as a C term, but it's the one in front of the x anyway. And so if this is an x transformation, the things inside the brackets are always opposite what you think. If you have, for example, if you have y equals 2x squared, something like that, you take your y value and multiply it by 2. In this case here, this is inside the bracket, so it's an x transformation. But what I'm going to do is take all my x values and divide them by negative 1/8. So if my x value is 4, so I'm going to take 4 and divide it by negative 1/8. Dividing fractions I can change to multiply and times, or change to multiply and invert this. So it'll be 8 over negative 1. So when I multiply, it'll be 32 over negative 1, which is really just negative 32. So that'll be my x value for that transform point. Hopefully those questions or explanations help you out.